Hello, today we're going to be talking about the standard form of a quadratic function. And if you remember last time we talked about vertex form of a quadratic function, so standard form is just a different way you could be writing it. And the target of this video is that you understand to graph quadratic functions that are written in standard form. So again, vertex form was written like this: y equals a times x minus h squared plus k. And the vertex was determined by your points h and k. Now in standard form, what we're essentially doing is multiplying this parentheses by itself since it's being squared, and then we're distributing the a within itself. I could go through that math, but it would take a while, and you can look that up on your own. And eventually you get to standard form of a quadratic equation, which is y equals ax squared plus bx plus c. Now, this form is much easier to plug into the graphing calculator, and vertex form is a lot easier to plot the vertex and draw it by hand. So in some instances you'll have to graph the equations by hand, and in some instances you will be able to use a calculator. And standard form is much easier to type into the graphing calculator. Now the same two pieces of information for vertex form can be applied to standard form, where we were finding the axis of symmetry, which is the line that goes directly between a quadratic function and the vertex. So that line is the axis. And the axis of symmetry within standard form can be found by taking the negative value of your b, so whatever this number is right here, and dividing it by 2 times a. And every axis of symmetry is going to have an x equals, so you always have to write x equals and whatever number that is. So sometimes it'll be a negative number, sometimes it'll be positive. It all depends on what this b and a value represents. C is not used at all in order to find the axis of symmetry. The only thing that C is used for is right here to find the y-intercept. Every single point that's going to be the y-intercept, x value is going to be equal to 0, because it's where it crosses the y-axis. So whatever value c is, the point 0, c is your y-intercept. Now in order to find the point for the vertex, your x value is always going to be the exact same thing that the axis of symmetry is, because the axis of symmetry goes through the vertex point, and all those x values are going to be the same. But the tricky part is, in order to find this y value here, what you need to do is take this value for your axis of symmetry, and you need to plug it into each of the x's inside the standard form of your quadratic function. So this is going to involve a lot of math and a lot of arithmetic operations where you're simplifying all of it down to one number and plugging it into that equation. So what I'm going to write for this y value is plug in negative b over 2a for your x. So looking at your original standard form of your equation, in order to get the y value of your vertex, you plug in negative b over 2a into each of your x's, depending on how many there are. Sometimes this will be a 0, this will never be a 0, but sometimes your b value may equal a 0 and you only have to plug it in once. So we'll go over a lot of examples in class that incorporate this, because this is the easy part and this is really, really easy, but this is going to involve a lot of practice and getting used to plugging things in and simplifying them down all the way. But even though it's written in standard form, you're still able to find an axis of symmetry and a vertex in all of your equations. Some forms are a lot more useful than the others. It just kind of depends on the situation. But what I would like for you to get is that standard form and vertex form both have its uses, and you need to be comfortable with both of them at the same time. Alright, thank you very much.